Hello, everyone. Welcome to Mining Now. I'm your host, Jared Downey, and today we have Orica Digital Solutions on the show. If you don't know who they are, you will. This is going to be quite a technical discussion. We're going to cover a lot of ground, so you will learn a lot about them. But if you're in the mining industry, you probably know who they are. And we have two guests from Orica on. We've got Angelo Labriola. He is the Senior Manager, Mine to Mill at Orica. And we have Greg Shapland. He is the Manager for Technology, IES, at Orica. Gentlemen, welcome to the show. Great to have you.
Thanks, Jared.
To be on.
Be here.
Let's start. Maybe Greg, we'll start with you. Maybe just a little bit of your background, sort of day to day with Orica.
Yeah, sure. So I lead the Integrated Extraction Simulator, which is IES, because it's too much of a mouthful. I lead the IES team. We have a number of software developers and metallurgists, and IES is a modeling and simulation platform developed specifically for the minerals processing industry. The actual platform started about 12 years ago, developing it 12 years ago, where we started to look at the ability to not just focus on different parts of a circuit, but looking across circuits and looking for the entire value chain and the opportunities there. So over the last 12 years, it's been developed primarily within a collaborative research center, and then in the last 2.5 years come across with Orica. So we help our customers with different types of challenges, and where modeling and simulation can really add some insights. My personal background is I studied civil engineering at University of Queensland, concentrating in geomechanics before getting into IT, and spent a number of years with Accenture before returning back to engineering and working in general mining packages and then mineral processing software.
How long have you been with Orica?
2.5 years.
2.5 years. So you're fully in, but you're it's a big organization, a lot of moving parts. The last episode I did, it was quite eye-opening how much ground Orica covers.
It is. It's the certainly in the digital solutions direction. It's a impressive vision, and we're moving towards that all the time.
Angelo, you've been with Orica for quite a while, if I understand, right?
Yeah, quite a long while. Coming on to about 30 years.
Wow. Okay, I didn't realize it was that long. Wow. So that sounds like, I mean, you don't look old enough that you had too many jobs before Orica then.
No, there weren't too many. I appreciate the compliment. I guess, I joined Orica actually even before it was called Orica. And the plan was to stay in the company for about 2.5 years, get a bit of exposure around mining, because you can do that when you work for a METS company, and then kind of choose which mining company perhaps I wanted to work in. But it never evolved like that. There's been so much variety in job roles and locations, and in the different types of scope of work that you can get into in Orica, including now in digital. And so I guess, honestly, over the last 30 years, there's been days of all sorts of things, including the odd days of frustration, but never a boring day. And so it's been a great company for me.
Well, what's your background? How did you what, like, university? What were you before Orica?
Yeah, so I studied geological engineering. I kind of wanted to go down what I thought was a virtuous path of environmental engineering. I did about a year of that, and that was actually pretty boring. A lot of soil sampling, water sampling, report writing. And so I got into mining through blasting. I needed that antidote of excitement, and never really looked back.
Well, so did you? I'm just curious with that 30 years. Did you? Did you have to go back and get any particular training, or did you just sort of train as you went as new opportunities came up?
I didn't need to go back to formal education, if that's what you mean.
Yeah.
I mean, through a geological engineering degree covers a lot of mining anyway. Most of the graduates went into mining. But really, in terms of blasting, probably most mining engineers, you do a little bit of blasting, but you don't do that much. So most of it you learn in the role. And then in a company like Orica, you're always afforded training opportunities, personal development. A lot of that is around, business management, commercial, sales, technical, all sorts of things. And I've had a lot of opportunities to be able to do that within the organization. And then a whole lot of exposure. It's a company that is happy to throw you into the deep end, work in different locations, some remote areas. When you work in a remote area, I worked in parts of the Asia business, you get exposed to everything. I was technical, but you overlap with commercial, you overlap with operations, you overlap with supply chain. And of course, you're dealing with your customers in all sorts of realms, coal, surface metals, underground, seismic construction. And so this huge array of experience has just always kept it interesting.
Let's talk about our heavy industry tour brought to you by Savannah Equipment, supplying mining equipment worldwide, and Geograph, solving customer challenges through innovation and design, higher performing parts, engineered solutions, on-time spare parts supply, and high-quality repairs. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry World Tour. Your partner in technical services, AMPS, have been industry leaders in technical services optimization systems and training since 2011. With a team of over 70 resource professionals, AMPS provides world-class support to mining technical services teams globally. AMPS builds the capabilities within teams on site to maximize results and unlock value in mining operations. With significant experience in operational underground and open pit engineering and geology, AMPS is passionate about delivering value to their clients across an array of professional services. If you're looking to improve your mine site's technical services, visit advancedmps.com or email partner@advancedmps.com today. L&H Industrial can custom engineer and build from the ground up any heavy equipment assembly or machine that you need for your operation. Their worldwide 24/7 field services network is on the job whenever you need heavy equipment troubleshooting, repairs, rebuilds, relocations, or replacements. And thanks to their specialized design and engineering and state-of-the-art manufacturing and repair services, they are a go-to international supplier for improved components and custom assemblies for heavy industrial machinery. Visit lnh.net to learn more.
Is that what sort of keeps you in the mining industry? That is all these. I mean, I don't even know how many episodes of mining I've done. Every time I do an episode, I'm like, okay, well, I know. I almost don't feel qualified to do the next interview after I've done the last one. Is it sort of that sense of there's so many moving parts to it that it just keeps you engaged?
Yeah, that's right. I mean, there's a few things. There's never a boring day. There's so many moving parts, as you say. It's a global industry, so our customers are all over the world, and I've been in a number of global roles since 2008. So I get to experience that diversity in our clients, what they do, where they work, what different cultures make up our client base. And the diversity within Orica as well, having that global footprint. So that's been great. And there's always a technical challenge. I kind of favour that. I guess that's my background. That's a bit of my DNA. But Orica is a type of company that is always forward-leaning with technology. So we're at the edge of trying new things and establishing new nascent technologies into successful commercial ventures within the organisation, and that always involves doing something that works for your client, that delivers some value. Otherwise, it doesn't turn into a commercial success. So
right,
there's a lot of satisfaction in that.
Yeah, what Greg, we're going to get into. I mean, we're going to get into very specific solutions that Orica is offering. But Greg, just kind of a similar question to you. What do you sort of find? I mean, you've been in the industry quite a while, so what do you sort of enjoy about it to this day?
Look, I think for me as a avid traveler, I really enjoy connecting with people all over the world. As Angelo mentioned, very global industry. Some weeks I can be talking to people in every continent.
Wow.
Last week Angelo and myself were in West Africa, talking to customers there and about their challenges and what we can do to help. But as part of whilst we were there, we were talking to people in Kazakhstan and also in North America and South America. So there's a lot of commonalities between different operations. But I think it's the differences which are really interesting, and those differences can be because of the ore body. Everyone's got their pet, the ore body they're with, and then how do you make the most out of that in terms of production? I kind of say, in the mining industry, you're not competing against each other. You're competing against Mother Nature and yourself.
Mm-hmm.
And so, talking to those customers, you always find some interesting challenges, either through the ore body, the plant, or in fact the people. Some are really keen to embrace new technologies. Others are, less so.
The mining industry is navigating a significant transformation driven by electrification, critical mineral dependency, and net zero targets. But balancing daily operations and capital projects can be overwhelming. Burns & McDonnell is your trusted EPC partner, supporting projects from concept to completion. With more than 125 years of experience, they stand ready to help the mining industry meet the demands of the energy transition. Visit burnsmcd.com to learn more. With Fender Dunlop, you are getting the best conveyor belting in the market. That's because they ensure the integrity of their conveyor belting by monitoring each step of the manufacturing process in their North American facilities. Focused attention is given to each belting order to guarantee that they produce a belt that will assist the customer in reducing operation costs, maximizing uptime, and improving revenue. Visit FenderDunlopAmericas.com to learn more. Is your mine site on track to meet net zero targets with reduced energy consumption from your green underground ventilation solution? Is your site receiving noise complaints or struggling to meet production goals due to noise-reduced operating hours? Are snowmelts or excess water putting pressure on your tailings dam, impacting your site's compliance or ongoing production? Are you sick of long lead times and limited customization of electrical products like switchboards and motor starters? Mindtech can help with world-class sound, power, water, and air solutions. Learn how Mindtech can help your site. Visit mindtech.com/innovation.
I think, I mean, at this point, for anybody who doesn't know, I think we should give Angelo, maybe I'll toss that over to you. Can you give us sort of a snapshot of who Orica is for, someone who's tuning in, never heard of the company? What would that summary look like?
Most people that may have heard something about Orica may have known them for what we've been doing for 150 years continuously. It's our 150th anniversary this year.
Wow.
We're a globally diversified company, but we're specialised in mining services and also in a digital realm, which we've opened up recently in our organisation. That's expanded us through to geotechnical and ground support industries, as well as ore body intelligence. But we are a globally represented player. Our core is explosives and mining chemicals into the mining industry. But as of the last few years, we have grown from a base of zero, really, a digital solutions function, which is both what Greg and I work for. That's now its own part of the Orica organisation, as in it's a visible standalone business unit, and that's grown, fair to say, pretty much exponentially over the past few years, and become a core part of integrating with the core business. So if I can sort of express that mildly, taking energy and making it intelligent and connected. So that the rock breakage process is aided by not just energy, but by knowing kind of where to place what and for what reason, and measuring it, and etc. So that's what the digital solutions function focuses on, and we've got an array of software, sensors, control systems, web applications that all service that family of technologies that expand our capability up and down the value chain, really to try to build that future of optimizing a workflow from mining all the way through to milling.
Taking something on like that, is it, there's about 3 different questions. I'm trying to decide which one to ask. I guess let's start with how it's been received by the industry. Has it been fairly, once you've actually developed the technology and started to integrate it in, is it because of Orica's position in the market, is it quite easy to sort of get that opportunity to get it out in the field and actually display your capabilities?
It's a good question, because we had to think long and hard about how do we do this. It was pretty clear in Orica that we wanted to embrace, what's been called different things in different times, but at one point it was called Industry 4.0, and now it's more digitalization.
Yeah.
But really that theme, Orica had to decide, how do we enter this space, and how do we enter this space for the betterment of our clients and for the betterment of our business, but do it in a credible way. To have a base of industrial manufacturing and supply and services to the mining industry, and then to enter the digital realm. How do you do that? But Orica's been a company that's had a core vertical across the mining value chain, and particularly in the space of blasting. So the first bit became, well, let's digitize that piece, the blast design function, the elements of taking a blast design and executing it in the field. How do you manage that piece? And that's a common challenge across the extractive industries. But it's a space where, when we started bringing technologies to the market, and we had some, we were in the software space, we were just never really an external digital player in the sense that we had some desktop software that assisted with the use of some discrete products that we had. But when we entered this space, that's where we started our focus. And the industry was actually quite interested in knowing, okay, well, Orica, you're a company that lives in this domain, and you're globally the biggest player in this domain. If you're going to start bringing some digital technologies to the industry around this domain, we're interested. So we had that brand permission to start in that space, and that was really the wedge into trying to expand. But the reasons for expansion have always remained very, I think, grounded and sensible. Because the upstream expansion is, if I'm blasting, I'm applying energy to rock, I need to know what the rock is. And so that takes you all the way up into ore body intelligence and back through to planning and scheduling. And then downstream, it's, well, if I'm applying energy to break rock and I'm fragmenting it and I'm moving it, then how do I understand how much I've moved it? And what does this fragmentation do to actually the most energy intensive and expensive part of the process, which is downstream processing? And so then we need to be connected to that. And so that led to a natural channel of digital technologies that provided opportunities for Orica to expand up and down the value chain, not by buying into, whole trucks or process plant mills and all that kind of thing, but by joining the digital value chain and always having that linked to our core.
Well, you said license. The brand sort of had license to do it. And what came to my mind too is there's probably also demand to do it as well, right? Because the clients are now looking for that sort of a demand across the industry. And I was curious, Greg, in your position, sorry, go ahead.
Sorry. No, that's okay. I had
Sorry, we're on, for the audience watching, we're on screens here, so sometimes it's hard to see when one person is done. So you're going to have a little overlap. But what I was going to ask just quickly, Greg, to you, well, not quickly, but is, do you deal directly with clients in your position?
Yeah, definitely. Yeah, definitely. As part of people using, obviously, the application, talking to them about how they use it, what problems they're trying to solve with it. It's quite a versatile tool, and there's different ways, and the good thing is being able to develop the platform, develop the models, and so forth. We're always listening to our customers and seeing if we can do some more that can help them.
Are you, and that sort of leads me to the next question, is that feedback, even from initial conversations, I would imagine there's quite a bit of hunger for it. Again, license to do it because you're Orica, but also the demand to do it because of what the market's asking for. Do you get a sense that people need it now? Like you can't really build it fast enough for them.
Yeah, there's a lot of talk in the industry, of course, about digital twins, and the industry is always dealing with uncertainty. So in terms of your knowledge of the ore body, there's you explore, you understand the ore body as you mine it. And so therefore a lot of it is about decision making under uncertainty. And having a model or a digital twin is really the most effective way of kind of understanding that through what if scenarios,
Right.
variability of the ore body. And so, in the past, I think that some of those, there's a saying, all models are wrong, some are useful. And I think in the past, there's probably been some skepticism of, okay, how good is the model? Is it telling me what I already know and so forth? But I think, we're now obviously in a different era, digital era. And, there's this real, I think, acceptance of, yes, we do need a good digital twin of our plant. I kind of say what is quite strange is that we build billion-dollar plants, spend well over $1 billion, and often we've only run a handful of simulations on them. We might have designed a piece of equipment here and sized it and so forth, but in terms of end-to-end simulations through the whole circuit, under different variability of the processing in the ore, it's only done a handful of times. So yes, there's certainly some really understand that there's technologies like what we have with IES that can really start to understand the risks associated with the plant that you have.
When you said about that, we only run a handful of simulations. It brought to mind another episode that we did. It was about simulation, but in conveyor systems, and they actually outlined, how different the simulation the different route the simulator provided and how much it saved. It was insane going through it. And you think that's just one little spot. That's one spot in the system.
Exactly. And it's the cheapest, most effective. And I kind of say, often we get into how good's your model? And it's kind of like, well, it's as good as the knowledge you have of your processes and the data that you have. It's, a sophisticated model is not going to, make you a better metallurgist or, create understanding that wasn't there. It's just a means of, having, for me, a lot of what if. What if this, if I change this? What if this was a disturbance that, I have to deal with? And so even with the current, I say start with your current knowledge, but it helps to de-risk. So if you are looking at different alternatives, then you want to and you want to do a plant trial, then you would naturally run different simulations to kind of then say, well, I can only try 2 things. What 2 things of these 5 should I try? So it's not necessarily there to give you the exact answer all the time, but it's certainly there to give you an understanding of where to avoid a lot of the time.
I'm assuming a lot of this ties in with machine learning. And then, Angela, I wanted to ask you, I saw a term when I was going through the notes. It's design of outcome, or design for outcome, DFO. Could you expand a little bit more of what even that terminology means, and then what it means within Orica?
Sure. So design for outcome is a technology solution set that really takes and applies data analytics and machine learning to be able to, well, as the term says, design for outcome. But there's a number of modules and products that we see evolving in this space. Essentially, if I was to try and give you a sense of a little bit more of a next level down sense of what that is, there's been design tools around for drill and blast engineers to be able to take what they know they want to do and then execute it, lay out holes and do blast timing and charging, and there's tools that make that efficient. But if you start to ask the question of, well, what specifically should I be doing in any particular area? Like not how do I apply what I know I want to design, but what should my design be to be optimum? That's a lot harder question. Because then you start to say, well, what do I really know about the rock, and how do I react to that? And what measurements do I have that I might be able to learn from and apply a better design or a higher resolution design? And so that's what this space does. And it takes advantage of the modern trend in the industry of having more and more measurements from more and more sensors, and also the mega trend. It's not just a mining industry's trend, but a global trend of being able to harness a lot more power and a lot more connectivity, for example, through cloud computing and through wireless networks now common across sites. So we're basically applying large data sets and we're applying analytics to be able to start to create tools that start to automate and assist blast engineers to be able to design specifically the rock that they're encountering for outcomes that are beneficial, not just in their drill and blast function, if you like, but across the mining value chain.
Throughout the interview, we talk kind of high level, then we kind of zoom in and out. But I was wondering, Greg, and we'll start with you, and then over to you, Angelo. Are there a couple of use cases that specifically to you sort of outline or can give the audience a good understanding in real world application, sort of what we're talking about and how it's applicable for them?
Yeah, sure. I think that it's probably easiest to sort of break it up into 4 main use cases, and I'll start at the highest level. So if you're in a plant, you're looking at sort of strategic planning alternatives there. So if you're looking ahead to the next 3 to 5 years through to the end of the life of the asset, then you rarely have the same plant from start to finish, and so you might be looking at an alternative additional grinding capacity. You might even be looking at different, more novel technologies in terms of much more energy efficient equipment, such as coarse particle flotation. So it's a great tool for looking at those alternatives and really comparing and contrasting them. Through to another use case is really operational improvement in terms of what you're doing. You mightn't be hitting your budget targets, and so you're then looking to try and analyze and identify where the bottleneck is and really what your options are in terms of alleviating that and maybe getting a little bit more production. Through to going right down into what's happening in the next shift. Where should I be? What's the operating strategy I should be operating under for this shift? If I have a breakdown through one line and I have to run on one ball mill instead of 2, what's the best way to respond to that? And that can be, there's a lot of value to be had if you can respond quickly to situations like that. So those 3 are just within the plant itself. And then if you want to look even broader than that, you can look at mine to mill alternatives, which is, looking at whether fragmentation is going to improve throughput, looking at your blends and, even, what is the way the plant should respond to those different sorts of feed conditions. So there are 4 broad areas, but each has their own value proposition.
Yeah, I feel like we could do an episode on each of those 4. Just separately, but I'll restrain myself and hand it over to you, Angelo.
Sure, Jared. I'll answer that question by way of a particular customer example because it's probably the way that I can make it tangible. I'm referring here to the design for outcome body of technology, and in particular that blastability domaining from drilling. So the particular client is in the northwest area of Western Australia, in the Pilbara region. And they were a foundation partner for us for building the technology design for outcome. I'm referring in particular to the Roy Hill mine, the iron ore mine in the Pilbara. So a huge volume production mine, but dealing with a lot of variability, geological variability, and subsequently hardness variability. They invest a lot in their block model to try and understand that as well as possible. But the degree of variability means that the best way to be able to understand that when it comes to applying explosives energy would be to be able to harness something from the drills. They have a fleet of autonomous drills packed with sensors. I'm not saying the data wasn't used, but it was difficult to be able to use that data from the time between drilling and blasting in a connected workflow, all the way through to on-bench operations. And so we implemented what I described before as a design for outcome technology and the whole workflow. And the use case for that client became, again, what's the lowest hanging fruit? If you had an understanding of your ore body that was, moderate to good, but not really high resolution, and you didn't want any impact to your productivity, you tend to blast conservatively. You maybe overall use a little bit more energy than you need to because you never want to kind of underdo it. And that's pretty standard practice around quite a lot of mines. But what we were able to do with them by implementing the blast domaining classification using the autonomous drill data is to be able to use that in time to match where the energy needs to go, so that where there's a hardest rock, you apply more energy, where there's softer rock, you apply less. Now, because of that particular operation, we also happen, that when I say we, I mean Orica, also happen to have the full explosive services contract, including mobile manufacturing units, or what we call the Buckmaster 7, which had at its heart a low plus control system. The jargon there means a smart connected system that connects the truck through to our digital portfolio. Then that means that all of these designs that could now hole by hole and within the hole start to vary what the energy placement should be. All of that could be channeled through to the truck and delivered into the field. And the way that the client extracted value out of that is that progressively they're able to step out their blasting patterns. So overall, using less energy, when they've stepped out and the rock's got a bit harder, that's okay. We can react in time with this technology to increase the amount of energy in that particular area. And where it's softer, it's less energy. So overall for them, that's meant about a 10 to 11% expansion of drilling patterns across the board. Now, that means that drills can be used to drill 10% extra real estate, which is 10% more production on the ground. It also means that reduction of cost in the order of 10% in drill and blast. It also means reduction in Scope 1 and Scope 3 emissions accordingly. So that's been the use case benefit, and that's just one, but it's a particular example for that foundation customer.
Question I quite often ask when we get into these technology discussions, because when we're talking here, it sounds amazing, but I always think about the onboarding, and I've probably said it multiple times in the show. When we try to integrate, I don't know, sometimes what seems like a very simple process within our own little company. And we say, hey, does anybody have any questions? And a week later, we're still fielding the questions, trying to get all the glitches. What does onboarding look like? If someone comes to you and says, okay, yeah, this is exactly what we want to do. What does that onboard look like? Is it a year? Is it hours of training? What does it actually look like on the ground?
Yeah, so there's a process, but it's a very, very well-defined process, and it involves a few things. The easiest way I think I can explain it is to give you an example.
Yeah.
So we have a module, as in a product within the design for outcome capability, that is about blast domaining. What do I mean by that? I mean classifying areas that we want to blast, or rock that we want to blast, specifically for purposes for blasting, which is different to what a geologist might want to know of ore versus waste, for example. Blasting engineers need to know particular things about the way rock is going to break. And so we have a blastability domaining tool as part of the design for outcome capability. So you asked about onboarding. What does that look like? Well, what that domaining tool does is it takes the most high resolution knowledge of the rock that we have, which starts with the block model, but that's not such high resolution because you can't drill you can't drill a hell out of the rock before you mine it. You drill to define to a certain level, but then you start drilling blast holes. Now, blast holes are spaced, 5 to 10 meters apart, depending on what mine and hole diameter you have. And as the drills are drilling, these days, a lot of drills are sensor equipped. And so they're recording data, they're recording what sort of effort, energy they're expending in the ground. And so we use that data to be able to understand how do we adjust the energy, particularly with some of the smart explosives trucks and products that we have now, how do we adjust the energy in the ground to deliver a most consistent outcome? Now, for the onboarding then, what do we do? Well, we understand the data source that's coming from, the drills. We either take the data that's coming from them, if they're so equipped, or we have our own sensors that we can add to that to provide a better resolution of data and a better quality of data for what we do. There's a particular sensor called a Rhino sensor, which does that.
So I just want to quickly clarify. So that this sounds like in some applications it's fairly brand agnostic. Then, just a clarification on that.
Yes, that's right.
Okay.
So we have a particular application that processes the data in the machine learning algorithms, but the sources of data can be agnostic from different drills and systems. Yeah. But to come back to onboarding, and I'll try and keep it more concise, we take the data from the drill systems, or we can add tools that help provide better data from drill systems. and we automate the data pipeline. So this data needs to flow fast. So we extract it from the drill systems and the servers, and we automate the data pipelines to do that. We work together with the client IT functions to be able to do that. And then the data flows in an automated way to our online algorithms. And then we provide a user interface for a drill and blast engineer. It's a type of thing that they're used to seeing, and it's hosted in an environment that they're used to going, such as our Blast IQ environment. And the onboarding process is pretty straightforward because they're dealing with blast polygons, they're dealing with shapes and processes that they normally undertake. And we're creating tools. Remember, we've done blast design tools for over 30 years. So we know what that environment looks like, we know what users do. And then we take that now more refined design, because now we've tried to match energy to rock, and we've got to deliver it to the field. And that's a really important part of the workflow. You described before integrations and how do they work. They have to work all the way through to execution. So now we've taken a reasonable understanding of the rock. By getting drill data at high resolution, we've now got a really good understanding of rock. We've been able to create a very efficient process in the design application for allocating energy around that. And now if you think about it, what we've done is we've taken something of moderate resolution and created something of high resolution. Another word for that, if you're a field operator, is that you've created complexity. I now used to do something across a whole bunch of holes that's pretty similar, and now I've got to do something that's maybe a bit different in individual holes or small groups of holes. So the flow through of that when it comes to implementation and onboarding is that we need a way of being able to get that instruction seamlessly to the field. Seamlessly means wirelessly these days. And we need to be able to provide it in interfaces that are user-friendly and practical to implement in the field. And we do that by way of tablets, or where Orica provides the technology through having an explosives contract and having a delivery system, what we call mobile manufacturing units that are connected and smart to the Blast IQ system. Then those trucks basically arrive at the hole and know exactly what to do in every single hole. So we take that whole process and digitize it from the data feed coming through automatically to the algorithms that run automatically, to user interfaces for drill and blast engineers that are familiar to them and work well with the tools that they use, to wireless transmission to the field, and not presenting operators with 400 blast holes and 400 sheets of paper for what they need to do for everyone, but with a digital connection on a user interface that is not so foreign to them to be able to use, because it kind of mimics what they've done with paper,
Right.
but it provides a way for them to interact with them. And so the change management process is there, and we support that through our Blast IQ support function and what we call a customer success program, which is a defined, structured way of being able to train operators and engineers. But that's how it all comes together into an integrated workflow that takes what the initial question was. You said, data science and design for outcome, which is really just the algorithm bit.
Right.
To create something that is implementable, if that's a word, from the drill data all the way through to delivery in the field.
That's if you've never been in mining before, that might not be a great explanation. But as far as someone who's actually, because I've asked that question many times on the show, and that was from a mining standpoint by far the best explanation I've actually gotten, that you can actually piece it together. Hopefully you can work with our editing team to put some visuals for the audience, because that workflow I've had trouble getting that, because I know pieces of everything you're saying, but putting it all together is very difficult. So kudos is what I'm saying on that.
It's critically important. If you only do one part of it, then you create some value in one area, but to be able, because we're talking about blast energy into rock in this particular instance, that only becomes valuable once you blast a rock. So it has to go all the way through to its end state.
Yeah, you mentioned at the beginning of the interview there's been some days of frustration, so it forces me to pretty much have to ask the question, in this whole process of development, what was or is the bottleneck of developing this entire system and delivery to client? Where was the slowdown in the R&D and the development and design process? If I'm allowed to ask that, I don't know if that's classified info, but
Sure. I mean, I mentioned frustrations before. It's more like kind of the things that are front head in their jobs, the ups and downs. But but to come back specifically to your question, initially there was the hard work that was required in the business case for a digital strategy within Orica, and that's not an insignificant piece of work, and rightly so. It needs to be done quite thoroughly because it requires an enormous amount of investment. And so, again, not frustrating, but a huge amount of work that needs to be done with that.
Just organization, right? Just the organization of the processes.
That's right, and all the key parts of the organisation coming together. Part of what we've done in our approach to digital solutions or our strategy, and this is quite deliberate in Orica, is that we have decided that a customer isn't just a contracted user of Orica explosives. A customer is any customer in the industry, so we can provide digital solutions fully to customers, whether they choose to purchase Orica explosives or whether they choose to purchase from a competitor of our explosives business. So there was a lot of work in shaping that strategy, shaping that rationale, and then executing it. How do you support customers where you don't have other things that you provide them? So you've got to build a support function for the digital solutions category, which is, again, part of the investment case and part of what you need to build up, but is essential if you're going to build a business in this space, which we've done.
Yeah, Greg, I want to bring you on. Your title's Managed Technology IES, Integrated Extraction Simulator. So that's, I'm assuming, based on what you were talking about, digital twin. That's what you were referencing earlier. Is that right?
Yeah, certainly. So we can model and simulate the entire value chain from, say, drill and blast all the way to final concentrate. If you're dealing primarily with plant personnel, then even integrating comminution and beneficiation is actually in one software is a step forward, because you have people with their own domain looking at grinding. You talk to somebody in comminution and it's all about size reduction, obviously, and energy usage, but they have often no idea of grade. What's the concept of grade? But then, of course, you talk to people in flotation or beneficiation, and it's all about grade.
Right.
It's about mineralogy. And so, just putting those two together, what happens in the plant is just putting in, crushing and grinding with float and bleaching and so forth is a big step forward, because, there's always trade-offs. Do I maximize throughput and take a hit on recovery, or vice versa? And it's never one answer all the time. And so just being able to allow somebody to click a button and run a simulation across that, you start to, instead of focusing on your targets like you have in comminution for grind size and energy usage, then you start to say, okay, what is my contribution to metal per hour, for example? And that's where you get real unlocking some opportunities that people don't naturally see, because they're trying to maximize or hit their targets within their domain. So then extending that upstream to blasting and starting to look at, okay, well, what about fragmentation? Okay, what is the sensitivity of my plant to finer fragmentation? Does it help up to a point, but not beyond that? And of course, blending and what sort of different blends and how that affects our flotation circuit. So I kind of look at, Orica had designed for outcome, and the outcome was often about the blasting outcome in terms of diggability and fill factors in terms of the vehicle, the trucks. But now with IES, we can start to, the real outcome is maximizing, dollars per hour, metal per hour. And now we can, take that sort of understanding and project it forward so that people, when they do design a blast, can actually consider whether there's opportunity to improve throughput as part of that blast design.
I want to have. It's a similar question that I asked to Angelo, but just with a little bit of I guess, a twist. Is that what infrastructure? Not sort of the onboarding question again, but the infrastructure question. To effectively run a simulation, what do they need to have in place to be able to carry that out properly?
Yeah, sure. Great question. IES is a web application, so to access it is very easy through a browser. I mentioned before digital twin, and it's a broad term. And if you're thinking of twins, you can think of some people who are twins that don't look that much alike, and others are identical.
Mm-hmm.
And so the always is, we're trying to capture their existing knowledge and codify that. And so sometimes when we build what I call as a flow sheet of, we put in models of different pieces of equipment and link them up as part of the process flow. Your understanding of every piece of equipment, sometimes people have a lot of understanding and detail of that, and you can use quite a sophisticated model, which is great, but you have to have the data for that sophisticated model. And other times people just have, if they're operating a plant, they have a lot of process historian data and lab data. And so we can even build a machine learning model on there. So to get up and running on IES is relatively straightforward if you have that knowledge at your fingertips. Often a lot don't, and so the process of building a flow sheet in IES is really collecting a lot of whether it be a survey that's done a couple of years ago, whether it's been process historian data, lab test work, and sort of codifying that into a flow sheet, into this digital twin, so that they can then run simulations under different ore types of different operating conditions. So I don't want to say how long's a piece of string, but some customers really understand the value of building a very high fidelity digital twin, and others are just there saying, no, I just need some directional information. So I'm happy to go with a high level model of what happens now and just pepper it with lots of data and find out directional opportunities to take.
If a mine if a mine hasn't broken ground yet, are you able to have discussion? Both of you can answer this. Just a sort of a general question: Is Orica getting involved in those initial design stages so that? I guess what I'm going to basically jump to is: Are there enough tools in place if from the beginning a mine puts all the sensors, all the data, all the equipment information, everything that can go into that, the connectivity, and just it goes on and on. We've done episodes about kind of all of it. How close can the digital twin get? How close can it get to that identical twin?
Yeah. So if I start from before you even got a mine, we do have a number of we have libraries of models or algorithms, and some are based on physics and chemistry, and they're very good for predicting unseen data. So certainly in design, that's your go-to type of models or algorithms there. You'll choose analogous sort of plant sizing and so forth, and start to work from there. And they're very good because, of course, you can't use a machine learning model because you don't have any data at that point, or very sparse data from lab data or pilot test work. So we can help people in Greenfield sites as part of designing and pre-feasibility studies and feasibility studies and so forth. And we've even had a customer build a flow sheet or a digital twin of the plant they think they were going to get based on the design.
Right.
And as they ran through plant commissioning, they kept on running simulations while they were going through plant commissioning, saying, "Does this align with what we thought we were going to get?" And then as they go, they can make fine tuning to the model in IES to then actually represent what they are getting in reality. So you're right. Once you start to have that data, you start to, very much we're in the era of learning models, whether it be machine learning and progressively getting to self-learning, where that data comes in, the pipeline and workflow is automated. It goes and takes data, runs a simulation, checks how well the simulation reflects reality. If there's outside a critical sort of threshold, it'll then go and retrain the model or recalibrate the model so that it's always sort of reflecting reality. So we can go from something very basic through to something very aligned or in tuned with reality.
Angelo, any thoughts to add on that?
I think Greg's covered it pretty well. Especially with that technology that's come into the fold and the skill team behind it, that allows the simulation from the ore body knowledge, which in the case of a new deposit will be whatever exploration's been done all the way through. As Greg said, there's no data to apply machine learning, so you really need all the experience and knowledge and the great physics models that exist to do that. And then through the other, core competencies that come with Orica around blasting, we know a lot about how to design, model, and configure blasts for all sorts of properties. Fragmentation, looseness, and then the distribution of explosives across a mining bench. So all of that helps with decisions like, well, what type of bench heights should I be using? What type of digging equipment should I be selecting, and what sort of fill factors might I get from that? And then what kind of drill units are best placed for this type of work? So, for the deposit that we're intending on mining. So we can help customers, and not just can, but we do help customers who are planning a new deposit and doing their pre-feasibility or feasibility studies. We help them quite often, and what Greg is referring to in particular with the IS technology, that's really helped, because now we're coming in much earlier as the mining company is making big capital investment decisions, not just in blasting, which is where they would normally have engaged Orica, but in process plant configuration setups and alternative processing technologies and strategies. IS is a fantastic platform for being able to model that. So Orica is getting more involved via its digital function way upstream, including to those Greenfield sites that you're describing.
I want to ask this to both of you as well. Angelo, we can stay to you and then jump over to Greg. Is how, in both your segments, just what would your recommendation be to, now we're going over to operating mines, how would you approach it? Before that conversation starts, what should they sort of be preparing? How should they be looking at things before bringing on this technology or starting the discussion, getting ready to share information? Because sometimes I've done different types of development projects, and sometimes if you're wanting the service, but you can make life a lot easier on yourself if you sort of know how to prepare to have the discussion. You can bypass a lot of the hurdles. What would your both of you, what would your recommendation be? Angelo, starting with you.
Sure. Look, in our experience with mines, I mean, we might look at a mine and say, let's say a copper mine, and say there's a lot of attributes that are common to copper. And therefore, this is a way to start a journey of a status quo to a form of optimization that's digitally enabled. But the reality through experience is that every operation is different and has particular different needs at any one point in time that are the priority for them, and also different motivators or drivers within different functional elements of the mining company. And so what we tend to do is, sure, we give an overview of the space that we provide, because as you mentioned right at the beginning of this interview, a lot of people don't necessarily, are still learning that Orica is bigger than what it's been for the last 150 years. But we start with a scoping study, an opportunity with them. And what that identifies is, it identifies pain points, it identifies low-hanging fruit, and it identifies initiatives that, I mean, if you talk about a digital transformation initiative across the mine, the creation of a smart mine, and that's an elephant, right? Where do you start biting that? Well, you need to start biting it where there is a chunk of definable value that can be delivered in a relatively short period of time, is a brick in the road of this digitalization or smart mine journey, but involves a discrete set of stakeholders, delivers value, and can be expanded upon. Now, that might mean something like a mine-to-mill study, and that could involve IS. It might mean processing people trying to debottleneck an area of their operation, or in pit operations and mine operations, it could mean some constraints related to fragmentation or equipment productivity not being able to be met because of some things that could be improved in blasting, utilizing data from drills. It could be anywhere, but what we'll do in the scoping study is we'll identify where those low-hanging fruit opportunities are. We'll work with the clients to identify what the relative value of that is. We'll bring the relevant stakeholders together and then bring together what they have, that is their own systems, their own data, what we can add to that, and how we can package that and help implement and drive the change management in order to be able to achieve that chunk of value. And then you move on to the next step.
Greg, what are your thoughts?
Yeah, look, I'd largely second what Angelo said. I think the reality is a lot of mining companies have been investing in digital infrastructure over the last 5-10 years, and I kind of liken it to any sort of infrastructure project. There's a lot of effort being put in, a lot of investment just to build the pipelines, just to bring that data together from disparate sources and so forth, and create the data lake, and some have called it the data swamp, and just to marshal that information, start to know what they have and clean it and so forth, and get it into a state that people can use it. And so a lot of that investment has actually happened. Some are still, that's always an ongoing investment. So a lot are quite ready to start to use it. And then it's a little bit of the chicken and egg. Once you start using what you have, then you start to identify what's useful out of it and what's missing. And what's missing. And so, where I talked earlier, when you're running simulations and you start to see a lot of variability based on, let's say, the rock hardness, and then you go, well, that's only because we've only got a couple of samples of, doing hardness testing on there, and we've domained this whole area, so we don't have a great understanding of our hardness. But look at the variability of performance because of that. And so I think the short answer is, I think most can just get started where they are, because, as Angelo said, it is a journey to build your quality of your data, but you'll still learn a lot getting stuck in now, and that'll help drive where you should go next.
I just wanted to quickly get an understanding. Is there sort of different, like we talked earlier, Angelo, you said about like some were brand agnostic, some you're integrated in with Orica sensors, there's sort of these different. Greg, is it the same with the IES? Is there sort of different configuration of customer?
Yeah, indeed. And it depends typically on their own capabilities and capacity for modeling and simulation. Certainly larger multinationals often might have still a corporate function that has specialists in modeling and simulation, and they see it as a real asset to their organization to be able to, a strategic capability, really. And so they might be quite happy to say, yes, please give me access to the software. It's software as a service. We have the models. We've been doing a lot of modeling and simulation ourselves, but just give us the subscription and we will load our own models on there. We will run our simulations, and we just want some of the capability of the platform of putting this all together, running mass simulations, because we're on the cloud. We can run tens, thousands, millions of simulations very quickly, and they're going, great, thank you very much. So they're at one end of the spectrum. At the other end are customers, like Angelo mentioned, who've just got a specific requirement. They've got a specific problem. They're looking to debottleneck their plant, and they want some help in doing that. And part of that, we might be doing some analysis of what's happening now, and then building a model to look at what, if they change something, what would be the impact out of that. So, but from there, they might say, I don't want a subscription. I just want you to help me identify what I should be doing. So between those two ends of the spectrum, some are have some capability, and we would build the model for them and hand it over to them, and they would run it, and others will continue to get us to maintain that digital twin of their plant and support them in their different sorts of studies.
Greg, I want to. I'm good. I'll start with you. We'll ask the same question for both of you. Where does it go? Where do you see this going? It seems like, well, Angelo, you mentioned, they called it 4.0 before, which is, I'm glad they're kind of moving away from that, because now how do you keep track of which one is 4 and which one is 5? It gets a little messy. So just digitalization is great. Greg, start with you. What do you see happening? If you had a crystal ball for the next, 5-10 years, where do you see it going? And then the same one to wrap up, Angelo, to you.
Yeah. So I think that what's interesting is through digitization, we're starting to get in the industry a lot of, I'll call it data intermediaries. So, I'll go back 10 years ago. It used to be, say, the metallurgist who would go out and take samples. They would go and monitor that through the lab. They would then take that data and analyze it. They would then build a model on it and start to run predictions, and then they would use that to make changes or do trials. A lot of that will be steps in between will be automated or through these data intermediaries like data scientists. And so there's, what we talked about, the pipeline, the data pipeline. We've got increasing number of sensors. We're getting better algorithms at cleaning the data and mass balancing and cleaning that up, and then better ways to express that knowledge to the decision makers. Until you get to a point where some maybe straightforward decisions are taken automatically, and only the very few kind of curly sort of challenges, trade-off challenges are given to individuals to make those sorts of decisions. So I think we're leading to a more automated world where through integration, so not only does the plant look at what's happening, but as the mine plan changes, that automatically gets reflected through running simulations in the plant, and so you have a better understanding of what's happening from actions you take in the mine through to the response in the plant, and therefore going back to maybe make corrective decisions in the mine again. So, different changes to blending and so forth. So I see a much more integrated, seamless sort of interaction where people are involved in the loop in making some of the really big, hard decisions where it takes these trade-offs.
Angelo, what are your thoughts?
Yeah, I echo what Greg says, but I might try to paint a more, I guess, a broader or expansive picture. The mining industry, by definition of the fact that so much of what we do use and experience is made of materials that are mined, is going to continue. Mm-hmm. But it faces huge pressures. It faces social license to operate. It faces environmental pressures, net zero decarbonisation pressures and commitments, all of which are good things. They're good pressures to have. The industry is already embracing digitalisation and trying to find ways for it to add value, make operations more efficient, and create more harmony amongst their communities in the way that they mine and process materials. And so that will continue. So I see a future that does work more towards the smart mine, does work more towards perhaps even the autonomous mine, although I think automation of processes and trying to extract the most out of what you have in the most energy efficient way, automation of that, I think is actually primary importance before you start trying to remove people from everything. But that's all part of the mix as well. So that's a direction I see it inevitably going. What does it mean? What does it mean for the industry and the players in it? Well, for us, it's been quite transformational to date, and I think that's going to keep going. We, having a business model for us that's agnostic of whether we supply the explosives energy. Of course, things are better together because we can do deeper integrations like that. but not making that an exclusive way to do business in siloed ways. That's going to be important for the industry going forward. Today, we see the miners as the integrators. They have to bring disparate technologies together. That needs to change, not to redress any form of balance, but because some level of integrations, workflow integrations, that need to be built among systems. And OEMs and METS providers are in the best position to do that, rather than have each separate mining company have to go about doing all of its integrations in that space. So I'm sorry, it's a bit long an answer. It does echo on the elements that Greg introduced, but overall, a future towards smart mining, but always embedded in workflows that make sense, because people are going to be in the equation for a while. And the players that are within the industry, greater collaboration, integration, and actually working together to build solutions that are complementary and add value, rather than just seen as competitive and separated at the fence.
Right.
These fences are not going to be conducive to an integrated smart mine of the future.
Yeah, and I would say anybody who puts those fences up, someone else will just move 10 feet down the road and integrate. it's a world that'll happen too fast. Yeah. Gentlemen, thank you so much for being on the show. We had so much to cover, and probably couldn't pack all of it in, because it would probably take 3 or 4 hours. But I hope you come back on again, because both of you have a very specific field that you're looking at. And there's so much to pack in. So thank you for answering all my questions. I hope you get great results out of this, so that we can do it again, because I would like to dig into some more specifics, actually. But this was good for just sort of putting some of the pieces together in a way that is actually quite difficult to do. I've had lots of these discussions, and both of you did it quite clearly. You could actually follow what was happening. So I appreciate it, and we'll talk again soon.
Excellent. Thanks, Jared. It's been a pleasure.
And thank you, everybody for watching. Yeah, a lot of information. You probably, while I'm asking questions, you probably had questions that you wished I'd had asked. I'm going to put Angelo and Greg's LinkedIn. You can connect directly with them. Of course, you can contact Orica directly as well to get more information. Thank you for watching, everybody. We'll put a link to their YouTube, their LinkedIn, their website, everything like that as well. Thank you for watching. We'll see you on the next episode of Mining Now.